Exercise 5.2.37. At a college production of the play A Streetcar Named Desire, 400 tickets were sold. The ticket prices were $8, $10, and $12, and the total income from the ticket sales was $3,700. How many tickets of each type were sold? If the combined number of $8 and $10 tickets sold was 7 times the number of $12 tickets sold. So here, we want to be clear before we do anything what our variables are going to represent. So notice I'm asked to find how many tickets of each type were sold. So I'm going to let my variables represent the number of each type of ticket that was sold. So X is the number of $8 tickets sold, Y is the number of $10 tickets sold, Z is the number of $12 tickets sold. So you want to take time to be correct and accurate on what you say here. A lot of times people will say X equals $8, Y equals $10, and that's incorrect, and it doesn't help you to write the equation. So be specific enough in describing your variable values. All right, so we want to write the equations that result here from reading the problem. So if 400 tickets were sold, that means the number of $8 tickets added to the number of $10 tickets added to the number of $12 tickets has to equal that 400. And that's our equation A, which I'll label these so that as I'm doing the work, I can let you know which equation I was using. So I want my work to be easily followed. All right, the equation B comes from the fact that the total income from ticket sales was $3,700. So if $3,700 was made in selling the tickets, every time I sold an $8 ticket, I make $8. So if I sell X of those, I make 8X dollars. I make 10Y dollars from the $10 tickets and 12Z dollars from the $12 tickets. So those monies add up together to make this $3,700. Okay, so I have to use the information in the last sentence to get the last equation. And so I just want to translate this directly. And it tells me that the combined number of $8 and $10 tickets sold, so that would be X plus Y, is the same as equals 7 times the number of $12 tickets sold, so 7Z. And I'm going to put this in our form that the other equations are in by subtracting 7Z from both sides of the equation. So X plus Y minus 7Z is equal to 0. And now if I take equation A and add negative equation C to equation A, my goal here is to eliminate X, but I can see that what's going to happen is I'm going to eliminate X and Y. So I multiply every term in equation C by -1. And so when I add this, not only do I eliminate the x, but I also eliminate the y. And I get 8z, when I add these two equations, is 400. So this is unusual to work with two of the equations and eliminate two of the variables. And that allows me to find that z is 50 right off the bat. So I've only worked with equation A and C. So I've got to bring B into this. So what I'm going to do with equation B is I'm going to replace z with 50. So 8x plus 10y plus 12 times 50 is 3,700. 8x plus 10y plus 600 equals 3,700. And let's subtract 600 from both sides to get 8x plus 10y equals 3,100. Alright, so now I have an equation that just has x and y in it. And notice I've also used all three of the equations. Now I want to get another equation that has x and y, so I'm going to use A, and I'm going to replace z with 50 in A. So x plus y plus 50 equals 400. And if I subtract 50 from both sides, x plus y equals 350. Now I'm going to choose to eliminate y next. Okay, so equation B is 8x plus 10y equals 3,100. Notice I'm going to eliminate y here. And equation A is, I'll multiply that by negative 10 in order to eliminate y. So equation A multiplied by negative 10 gives me negative 10x minus 10y equals negative 3,500. Now I'm going to add these two together. The y's are going to drop out of the problem, and this will allow me to solve for x. So I get negative 2x is equal 3,100 plus negative 3,500 is negative 400. So dividing both sides by negative 2 gives me x equals to 200. So I have x and I have z, and all I need to do is use one of the three original equations. I'm going to use A, and I'm going to replace, remember that equation was, I'll write the equation first, x plus y plus z equals 400. So I'm going to replace x with 200. I'm trying to find y, and I'm going to replace z with 50. And notice y plus 250 equals 400. If I subtract 250 from both sides of the equation, I find out that y is 150. And we have all of our unknowns, and we can answer our question. So 200 $8 tickets, 150 $10 tickets, and 50 $12 tickets were sold. We want to make sure we answer this with a complete sentence. Alright, so that's 5.2.37. You want to answer this with a complete sentence if you're working a open-ended exam.